Oh, are we on? Are we filming? Oh, I must have dozed off. Welcome to Chapter 11 Solutions. That reminds me, make sure you get plenty of rest while studying for the GRE. Being well rested improves your retention. Number one, we're asked to find the volume of this rectangular prism that has dimensions of 20 by 5 by 8 feet. Notice that the question asks us for the volume in cubic inches. So this is a really straightforward problem as long as we remember to do the conversion. So volume is simply the length times the width times the height. And a lot of times students will multiply 20 by 5 by 8 and then they'll remember to do the conversion, but they do the conversion at the end. They multiply by 12 to get it into inches. However, each one of these dimensions has to be converted into inches. If you save the conversion to the end, you have to multiply by 12 cubed to account for the fact that there are 3 dimensions. So in order to avoid that, you can do it at the beginning, so you're not in danger of forgetting. So 20 feet, 20 times 12 is 240. So 20 feet is 240 inches. 5 feet is 60 inches. And then 8 feet is 96 inches. And then you can just go ahead and multiply 240 by 60 by 96. So 240 times 60 times 96. You definitely need a calculator for this one. You get 1,382,400 cubic inches. And since it's in cubic inches, this is all you need to type into the solution box. Number two, we're asked how many buckets of paint we would need to paint this box, given the same dimensions of 20 by 5 by 8. And also given that 1 bucket of paint can cover 75 square feet. So this is a surface area question, as you may know, because we are covering just the outside, we're covering all of the surfaces. So if you imagine a box has 6 sides. The front and the back of the box have the same dimensions, the top and bottom have the same dimensions, and the 2 sides have the same dimensions, which is why after you find the area of each face, we're multiplying by 2 to account for the front and back being the same and the top and bottom, etc. Okay? So the length times the width, for example, the length times the width would be this bottom face. This is the width times the height. Another word for width is your depth. So your depth times your height would be this face. And then your length times your height would be your front face. And since we're doing it times 2, also times that back face. Okay? One tip, if you forget this formula, just remember that each of the dimensions has to be multiplied by the other dimension. So length and width, width and height, and length and height. And the order that you do this in does not matter. And then just remember to double it. Okay, so first thing we need to do is find the surface area. So our length times our width, length times the width is going to be 100, plus our width times our height is 40. And then the length times our height is 160. So you add this up, you get 300 times 2. Our surface area is 600 square feet. Okay? So our total surface area is 600 square feet, and we are asked how many buckets of paint that we need. So we simply do 600 divided by 75 because we want to know how many times 75 goes into 600. So 600 divided by 75 is 8. So we need 8 buckets of paint to cover this box completely. Number 3. For number 3, we're asked for the surface area of the 2 figures that result from cutting this rectangular prism in half along its depth. So as it says in the problem, the depth becomes 2.5 feet instead of 5 feet. Okay? So this width is now 2.5. So it's a surface area question, but we're going to have 2 figures. So whatever we get for the surface area is just going to be the surface area of 1 figure, and then we have to double that surface area, okay? Because we're cutting this in half. So let's find the figure of the first one. So the length times the width is 20 now times 2.5 feet because we cut it in half. So 20 times 2.5 plus 2.5 times 8 plus 8 times 20. Okay, then we have to double that. So 20 times 2.5 is 50. 2.5 times 8 is 20. And 8 times 20 is 160. Okay, that gives us 230 when we add it together, times 2 for a surface area of 460. Now remember, that's just for one figure. So to find the surface area of both figures, we just double it. And 460 times 2 is 920. So it's 920 square feet, and 920 is the answer. Number 4. In number 4, we're asked to find the length of the longest diagonal of this figure. So the longest diagonal could be, let's say, from the upper right back of the box to the lower left front of the box. So we're cutting through the box, and we're going across the box, and we're going from up to down. So that gives us our longest diagonal. Okay? Now the formula for the longest diagonal, or the longest diagonal in a rectangular prism, is the square root of the sum of the length squared, height squared, and width squared. Once you know this formula, it's a simple plug-in problem. So the length squared would be 20 squared, which is 400. The height squared is 8 squared, which is 64. And the width squared is 5 squared, which is 25. So this is the square root of 489. And if you put that into your calculator, you're going to get approximately 22 and 11/100ths. And we're asked to round to the nearest integer, so the answer is simply 22. Number 5. Number 5, we're given information about a cylinder, and we are asked for its volume. So the diameter of the cylinder is d, and the height of the cylinder, we're told, is 4d. So the formula for the volume of a cylinder is pi r squared h. Don't get that confused with the surface area of a cylinder, which is 2 pi r h. So it's actually pretty simple to keep them separate in your mind or clear in your mind. If it's the area of the circle times the height, remember the area of the circle would be like filling this whole base in, times the height, you'd be filling it in all the way down. So we're talking about completely filling up the inside. For surface area, we're talking about the outside. So that's why it's 2 pi r times the height for surface area, because you're going around the circle, and that's the circumference, and you're going around it all the way down to the bottom of the figure. Okay? So all we have to do is plug in this information for the volume. So volume is pi r squared h. R, in this case, is 1/2 of d, because the radius is half the diameter. So you can say d over 2 squared times h. We want to substitute in 4d for h because our answer is going to be in terms of d. Okay, now all we have to do is simplify. So we have our pi. You have to square both the numerator and the denominator, so you get d squared over 4 times 4d. If you want, you can place this 4d over 1. It might be a bit easier for you to see visually that you can cancel these 4's out. And then your final answer then is going to be d squared times d, which is d cubed. Remember, this is d to the first power, and you add your exponents. So you get d cubed pi for number 5. Number 6. For number 6, we're given 2 cylinders, and we're told the dimensions of the 2 cylinders. The first cylinder A is completely full, and cylinder B starts out empty. We're told that half of the liquid from cylinder A is poured into cylinder B, and we're asked at that point what fractional part of cylinder B is full. So the first thing that we have to do is calculate the volume for both of our cylinders, because we need to know what the capacity is. Once we know the volume of this, we'll know how much liquid we're pouring into cylinder B, and then the fractional part will be how much we poured in divided by the total capacity. So again, for volume, if you forget what that is, let me just write generally the volume of a cylinder is pi r squared h. Okay, so I've already filled it in here. The volume of A is pi times 5 squared times 8, because 5 is the radius and 8 is the height. Make sure that you're only squaring the radius, okay? Sometimes students get that wrong. They do 5 times 8 and then square the whole thing, Okay, that would be wrong. So 5 squared is 25 times 8 is 200. So the volume of A is 200 pi. We poured half of the liquid that was in here into here. So cylinder B now has 100 pi units in it. But what is its total capacity? So the numerator is going to be 100 in pi of the fractional part that's full. And let's find out what the denominator is. That's that total capacity. So again, the radius squared times the height. The radius is 12. So 12 squared is 144. 144 times 9 is 1296. So we're dividing by 1296 pi. To figure out the fractional part full, you want to know how much liquid is in there divided by how much liquid could potentially be there in order for it to be full. So now you just simplify. You can divide by pi. You might notice that both our top and bottom numbers are divisible by 4. If you don't, you should definitely notice that they're both divisible by 2 because they're both even. And if you divide by 2, you can simply divide by 2 again. But in this case, we'll just divide by 4 from the beginning. So we get 25 over 324. So cylinder B is 25 324ths of the way full. So the answer is A. That concludes Chapter 11 Solutions. I hope that this chapter went well for you. Make sure you do the associated problems in the official guide as suggested in the study plan. And we will see you back for Chapter 12.